Section 9.8, Marginal Functions in Economics. So we learned about revenue and cost and how those two relate to profit in finite mathematics. What we're going to do now is look at how we can look at the derivative with respect to these functions and what that really means. So we should know that if you're looking at the derivative, any one of these functions, the word marginal will be used, and that really just means, one additional. That's what you want to be thinking of when you see the word marginal. And also that marginal is going to imply the derivative of whatever the function is. So therefore, the marginal cost function, C prime of x, is actually measuring the actual cost incurred by producing just one more unit of a certain commodity. So let's say you've produced 5,000 toasters. If you wanted to figure out C prime of 5,000, that's really telling you how much more it would cost to produce just one more of those. In other words, the 5,000th first toaster. Okay, so average cost, total cost divided by x. C bar of x. That's how the total, the average cost function is notated. Again, anytime you see the derivative symbol here, you're looking at the marginal of whatever it is, marginal average cost function in this case. Okay, let's see. All right, revenue functions. So again, this is review. We've talked about this before in 128. If you're given a unit price function, so that's going to be, how much each unit of the commodity is going to cost. It's going to be some expression in terms of x, where x is the quantity of the commodity demanded. Well, what's revenue then? Revenue is equal to that unit price function times the number of units, right? Let's say a toaster is 20 bucks. Well, okay, if you have 1,000 toasters, if x is 1,000, what's that going to be? 20 times 1,000 is going to be 20,000 total revenue. All right, and that's what's going to be coming in, right? Revenue is money coming in, and cost is what cost equals how much the money is spending to produce, manufacture whatever the commodity is. And again, our prime of x is the marginal revenue function. So what does this tell us? The actual revenue realized from the sale of one additional unit of the commodity. Review. Profit we know is equal to revenue minus cost. The P prime of x is, again, there's the derivative. This is going to be the marginal profit function. And you can read this. This tells us what it actually means. This provides us a good approximation of the actual profit or loss realized from the sale of the x plus first unit of the commodity. So again, in my earlier example, if we had 5,000 toasters, okay, that were already sold, how much more in profit would we be making on the sale of the 5,000th first commodity? We could do that by looking at P prime of 5,000. Okay, so let's look at some examples. All right. So suppose the relationship between the unit price P in dollars and the quantity demanded X of some commodity is given by this equation. So again, this is our what? This is our unit price function, okay? And don't worry about this. This is just a restriction on the domain of x, because for whatever reason, once you get past this number, this function is not relevant any longer. But I wouldn't worry about that. So let's do one thing at a time here. What would be the revenue function? So R of x, remember, is going to be x times p. So in this case, you get what? Well, you get x times whatever this unit price function is equal to, which is this. And so R of x would be equal to what? Well, negative 300 x squared plus 501x. All right, that's so far so good, I hope. That's easy enough. And then it asks us for what would the actual revenue realized from selling 7,001 units be equal to, assuming that 7,000 units have already been sold. Okay, so this is actually another algebra question, And what we want to do here is this. We want to look at R of this, 7,001, minus R of 7,000. So again, we're just trying to figure out how much more in revenue we would realize from selling this number of units as compared to this number of units. So hopefully it makes sense that you could figure out the total revenue for this number of units and then subtract from that the total revenue from this number of units. And you could do that any way you want. You just plug in 7,001 into this X, get that number, then plug in 7,000 into this X and get that number, and you end up getting, I think it's about $81. I think it's approximately $81, okay? So that would be how much more in revenue you'd make based upon this question from the selling of one more unit compared to this number of units that have already been sold. So let's see how that relates to the next two questions. So first of all, what is the marginal, and I'm sorry, I misspoke on where you'd plug in these numbers. You'd want to plug them into these X's, okay? Not this one. So hopefully you're still following along here. Again, this is why you do not smoke crack when you teach mathematics. These two numbers should be plugged into these X's to ultimately get this value, okay? Hope I was clear on that. Okay, all right. So what's R prime of X? Well, look at this function. The derivative of this function would be what? It'd be negative 0.06x plus 501. Okay? So this is the marginal revenue function. All right, now we're going to find out what this is equal to. So to figure out what this is equal to, clearly, I hope I do a better job this time. You're going to plug in 7,000 into this X, and that's going to give you the marginal revenue at 7,000 units. And it turns out to be, again, about $81. Okay? Well, what's this mean? Interpret your result. This means that the actual revenue realized from the sale of the 7,000th first unit is equal to $81. And note, they are the same. Now, if you went out to the nearest cent or tenth of a cent, it may be slightly different, but they're going to be awful doggone close. Okay. All right, lastly, let's look at this example. We're not doing everything we could be doing in Section 8. I just want you to be referring on the main things. So make sure you still know profit, revenue, cost, how those are related, and then make sure you can determine the derivative of any one of those three and, interpret your result if you're asked to do so. So we're referring to the previous example, all right? And now we're told the cost of producing X units of the previous commodity is C of X equal to this. And the first thing we're trying to do is find the profit function P. Well, remember, P of X is equal to what? It's always equal to revenue minus cost, okay? So, well, in this case, P of X then would be equal to what? So refer to the previous example. All right, previous example, we had what? There is R of X. Remember that? That's the one we need to use, right, for this question? Okay, perfect. So let's write this down. Negative 0.03x squared plus 501x. I'm getting this from the previous example. This is our revenue model, okay? And then minus what? Minus what? The cost model, which is 125x plus 150,000. And you simplify this, and you end up getting your profit model, which would be equal to this. 300x squared plus 376x minus 150,000. There's your profit model. Okay. Letter B is asking us to find the marginal profit. So all we got to do is find the derivative of this function, which would be what? It'd be negative 0.06x plus 376. Okay? And then lastly, we are to compute P prime of 7,000. and interpret our result. We should already know what the interpretation is going to be. Okay, what is the interpretation? Well, you're going to get a number, and that number is going to be approximately the profit realized, okay, on the sale of the 7,000th first unit. So one more additional unit. So you see derivative, you're just thinking one more than whatever this is. All right, so you would, using your calculator, plug in 7,000 into this derivative. So everywhere you see an x, you're going to replace this only x with 7,000. And I am getting about negative 44. So what does that mean? This means the profit realized would actually be a net loss of $44, okay, on what? On the sale of the what? Of the what? Of the what? Of the 7,000th first unit of whatever this commodity was, okay? So again, you see derivative, you're thinking in your explanation, what is it really telling us? Well, if you were to just look at one more than this number, okay, that's how much you're gaining or realizing in profit based upon plugging this into the derivative. In this case, we are actually losing money if we were to manufacture and sell 7,000 units of whatever the commodity is. And that can certainly happen. That's why we're doing these models. That's why businesses do these models to make these projections, so make sure we're earning as much as possible. Okay, we'll discuss this more in class, and I hope you're staying safe, and we'll see you soon.